So we are on to a new unit. This is Unit 5, Section 1, and here's the I can statement. I can solve one-step equations with rational numbers. So now that we've spent all that time talking about rational numbers, getting comfortable with fractions, decimals, percents, all that sort of stuff, now we're going to go back and review how we solve equations, but this time instead of always having equations that have integers in them and only integer answers, remember positive and negative whole numbers including zero, we're going to have equations that have fractions in them, decimals in them. The answers might be fractions and decimals. So we're going to go through as the warm-up here, and we're going to take a look at this equation right here. And what I'd really like is for you to think about, how would you solve this? Like, if you weren't given any instruction, if you just had to take a good guess as to how to solve this, what would you do? And then maybe we can talk about it. So pause the video for a second, try this and see what you come up with, and then we'll go through a couple different ways to solve this. Okay, so we're ready to go through and solve this. Here's one thing that a lot of people would do without any instruction. They'd look at this and say, okay, well, we need to get the x by itself. This term is by itself. So we've got the variable on one side. We just don't have it completely by itself. We've got a numerator of 3 and a denominator of 4. So what some people would do is they'd say, okay, well, I'm going to get rid of dividing by 4. So we're going to multiply this side by 4, and we're going to multiply the other side by 4. And remember, if there's a fraction in the problem, you might as well think of everything as a fraction. So I'm going to think of it, and I'm actually going to go ahead and write it as a 4 over 1. And then we're going to go through and see what we get here. So the 4 cross cancels with the 4, so that does exactly what we wanted, undid the dividing by 4. So then we're left with a 3x. And then over on this side, we have a 9 over 10 and a 4 over 1. We could multiply straight across, which I would not recommend. You'd end up with 36 over 10, and then you end up reducing. I'd really prefer that you not do that. I'd really prefer that you practice cross-canceling. So that's a really good skill now, and it's a really good skill down the road. So we'll notice that the 10 and the 4 have something in common. 2 goes in here twice, and 2 goes in there twice. Sorry, 5 times. So you'll notice that there's nothing else that I can cross cancel or anything. So I'm going to do the 9 times the 2, that's an 18, and the 5 times a 1, that's going to be a 5. So now this is starting to look a lot more familiar, because what we have here is we've just got a 3x. So this is implied multiplication here, remember. So this is 3 times x. So we need to undo multiplying by 3. Well, here's where we run into an issue if we're just kind of brute force going through and doing this. If we divide this side by 3 and then divide this side by 3, this side they do cancel each other out, but then the question is, what do we do with this? If we were to think of this as a fraction, 3 over 1, we can think of this as something called a complex fraction, but that gets to be a little bit difficult. Some people might, instead of using the horizontal fraction bar, and I wouldn't recommend this, they do something like this, divide by 3, which is okay. I mean, we can deal with that. Either way, what's going to happen with this is, I'm going to write it as 3 over 1. We're going to end up multiplying by the reciprocal, and the reciprocal of that is 1/3. Okay, so if you think about this, on this side we were taking a fraction and dividing it by a fraction, so we flipped it over and multiplied. Another thing that we could do here is we could just say, hey, I'm going to multiply this by 1/3. So we're multiplying both sides by 1/3. We're doing the same thing to both sides. So now I can cancel the 3 with the 3. We're left with an x. I can do a little bit of cross cancellation here. I'm going to cancel the 3. 3 goes in once, 3 goes in 6 times. So we end up with an answer of 6/5. Now that's a perfectly good way to do it, but man, that's a lot of work. There's a whole bunch of stuff to go through. It can get a little bit confusing when we've got this whole number here. We're dividing both sides by that whole number, or on this side we have to think of it as a fraction, all that sort of stuff. Well, there's actually a lot easier way to do this problem. So I'm going to do 3 over 4, 3/4 x equals 9/10. Now stop and think about what we did here. We undid the dividing by 4 by multiplying by 4, and we undid the timesing by 3 by dividing by 3 or multiplying by 1/3. Well, if you think about it, we can actually take care of those two steps in one single step, and this is kind of a clever thing that I would keep track of, because you're going to use this quite a bit. We often will run into a fraction that's in front of a variable, a fraction coefficient in front of the variable. And you'll hear me say this over and over again, so make sure you get this figured out. I'll talk about it down below. In fact, I'm going to put a little asterisk by it right now. The way we get rid of a fraction in front of the variable is we're going to multiply by the reciprocal. So if we multiplied x by 3/4, to get rid of that, we're going to multiply by its reciprocal. Now, reciprocal is a fancy word that means we're going to flip the fraction over. So we're going to multiply this side by 4/3. which means we're going to do the same to the other side. So we're going to multiply that side by 4/3. Now notice what happens here. In one step I can cancel the 3's with the 3's, the 4's with the 4's, and I'm left with an x in the denominator. Now let's take a look over here and let's see what we can cross cancel. We've got a 4 and a 10, so 2 goes in here twice, 2 goes in there 5 times, 3 goes in here once, and 3 goes in there 3 times. So what we're left with on the top is 3 times 2, which is 6, and on the bottom we're left with 5 times 1, which is 5. Now you'll notice that we get the same answer either way, but this is a lot quicker way to do it, a much slicker, cleaner way to go through and do that. That's not really a shortcut. What we're doing is we're getting rid of multiplying by 3/4 by timesing by its reciprocal 4/3. Now, as we go through and we review how to solve equations and things like that, don't forget all those basic principles that we learned when we were solving equations with integers. But I do want to remind you of a couple of important things that they're really important to understand when we're solving equations, especially with rational numbers. The first one is this: if there's a fraction in the problem or in the equation, you might as well think of everything else as a fraction. So for instance, on this problem right here where we were thinking of that as a 3, we might as well think of that as a 3/1. So if there are fractions in the problem, you might as well think of everything else as a fraction. The next one is a question. How do you get rid of a fraction in front of the variable? And that's what I was talking about up here. And this is a nice quick way to do this. So how do you get rid of a fraction in front of the variable? You multiply both sides by the reciprocal. That's how you spell reciprocal. And again, reciprocal is just a fancy word for flipping the fraction over. All right, and the next one is, when is it okay to write your answer as a decimal? So you'll notice that several of these problems down here, some have decimals, some have fractions. It's okay to write the answer as a decimal when the problem is written with decimals. Other than that, we really like writing things in terms of fractions. So make sure that the only time you're going to write the answer as a decimal is if the problem was written as a decimal. So if you take a look at these problems right here, I've got 6 problems showing on the screen right now. There's only one of them that's written with a decimal. So that's the only one that we're going to answer as a decimal. Now, just a word, you can use your calculator on these, no problem. Hopefully you're pretty adept at using that now. Hit the right keys, all that sort of stuff. Make sure you're typing it in correctly so you get the right answer. I'm going to go through and I'm going to do each one of these. I'm going to do them mostly by hand. If you want to double check on the calculator, then that would be just fine. So here's what we're going to do. On this one right here, we need to get the y by itself. So we're going to divide both sides by 0.6. Again, we don't divide by 0.6y, just the 0.6. That's the only thing we want to get rid of. We want to leave the y over here. So negative 0.6 over here. Those are going to cancel to be at 1. Negative divided by negative is positive. 0.6 divided by 0.6 would be 1. So we're left with a y on that side. So we're in great shape here. Positive divided by a negative is a negative. And then we've got 7.2 divided by 6. Now, if you're pretty good at working with decimals, and I'm hoping you are, you might remember that we can move the decimal over one place on both of these. So that would be 6 into 72, and that would be the same answer. So our answer should be 12, but let's just double check that on the calculator and make sure. So I'm going to slide this over here. Always a good idea to double check, especially if you've got the time. So we're going to divide by negative 0.6. And the calculator gives us that answer of negative 12. So we're definitely right on that one. Now for these other ones, if you need to use your calculator, please go right ahead. But I'm going to do most of these by hand. So on this one right here, I need to get that x by itself, which means I need to get rid of subtracting 2/5. So that means I'm going to add 2/5 to both sides. So if I add 2/5 to both sides, those cancel to be 0. So we end up with an x over here, and then I've got 1/4 plus 2/5. Again, go ahead and type that into your calculator if you want, but you might find that it's actually not too bad to do this, and also good practice. I'm going to get a common denominator of 20. Multiply this one by 5, so that's going to be 5/20. Notice that's same as 1/4. And then I'm going to multiply that by 4, so that's going to be 8/20. So now I can add them together. I've got a common denominator, so I've got 5/20 and 8/20. Remember, the 20ths, those are the size of the piece. That's what we talked about in that last unit. So if I've got 5/20 and 8/20, I've got 13/20 altogether. The size of the piece doesn't change. The denominator just stays the same. Okay, here's another one. Now, on this problem right here, we've got a fraction in front of the variable. So I will tell you that the easiest way to do this and to think about this one is we're going to multiply both sides by the reciprocal. So we're going to multiply by the reciprocal of 1/4, which is 4/1. So I'm going to multiply this side by 4/1 as well. The 4's are going to cancel, and that means we've just got 1's left. So we've got an x over here. 2 goes into 2 once, 2 goes in here twice, so this would be a 2. We could also back up and we could think about the problem this way. We could think in terms of what is 1/2 of 4? 1/2 of 4 would be 2. So either way you want to do that is totally fine. And again, if you want to check your answer on the calculator, that's fine with me. Let's take a look at this one right here. Again, a fraction in front of the variable, so we're going to multiply by its reciprocal. The reciprocal is 3/2, so we're going to multiply both sides by 3/2. The 2's will cancel and the 3's will cancel. That'll leave us with an A. And then over on this side, again, sometimes it looks like, oh gosh, I can cancel out those 3's. You can't. You can only cancel out with the top to the bottom or bottom to the top. We can't cancel these out because they're both in the numerator. When we multiply those, we end up with a 9. Can't cancel these guys either, so we end up with 9/8. So there is our answer, so 9/8. And I'm going to make that look more like a 9 than an A, so there we go. This problem right here, again, fraction in front of the variable, so we're going to multiply by the reciprocal, so I'm going to multiply by. Now stop and think about what the reciprocal of -5/6 would be. We take that and we flip it over. That doesn't mean it changes signs, so that's going to be -6/5. Now, if we did just multiply by the positive, if we thought, oh gosh, I've got to do everything here being the opposite in that, what's a positive times a negative? Well, that would be a -A, and that's not what we want. We want a positive A, so we need a negative times a negative. So we're going to multiply both sides by -6/5. So negative times a negative is a positive. 5 divided by 5, 6 divided by 6, so those cancel to be a 1. Let's take a look here. Positive times a negative, the answer would be negative. And notice that something unique happens on this one. The 5's cancel, the 6's cancel. So the question is, what's the answer? Since everything canceled, is it a 0 or is it a 1? Remember, when we cancel things through multiplication and division, there's always a 1 left, so the answer on this one's -1. And again, feel free to double check on your calculator, and feel free also, we haven't done this in a while, but feel free to take any one of these and plug them back in and check and see if they actually work. So if you take each one of these numbers and plug them back into the equation, do the two sides actually equal each other? They will. It'll work out that way. So the last one here, before we get to the few at the bottom, we've got y plus 4/7 equals 5/3. I'm going to subtract 4/7 because that will cancel to be 0. So we're going to subtract 4/7 from both sides, so those are going to cancel. So we end up with y over here, and then I'm going to go ahead and get a common denominator. If you'd like to type it in your calculator, that'd be fine. We're going to use 21sts here. So we multiplied by 3, so that's going to be 12 21sts, and then we multiplied by 7, so that's going to be 35 21sts. So let's see, that's going to be 13 in the numerator and 21 in the denominator. So y equals 13 21sts. So there's our answer there. Now, if we take a look at these last couple here, these are just more thought questions before we do tomorrow's discussion. And that is, I want you to think about the answers to the following questions and how you get them. So most people know immediately what the answers to each of these questions are. So what is 4 less than 10? What is 4 less than 10? Get that answer in your head. What is 5 more than 7? What is 5 more than 7? So I want you to spend some time thinking about those and thinking about how do you get the answer. Everybody knows what the answer is, but think about what operation, add, subtract, multiply, divide, and what order you put those in order to do those. So go ahead and get started on today's assignment, and then we'll talk about this more tomorrow.